This is part 2 of the Chapter 10 lectures. We left off here with the way that we name skeletal muscles. So another way that you can name skeletal muscles is where they're located. This is my favorite muscle right here, the sternocleidomastoid. So the sternocleidomastoid has 3 attachments. The sterno, of course, means sternum. Cleido refers to clavicle. So it attaches to the sternum and the clavicle, and it inserts. So the sternum and the clavicle would be called the origin, because the origin is named first. And the insertion is the mastoid process of the temporal bone. All right, and then also muscles can be named for their action. They're probably, for me anyway, the hardest muscles to learn are the flexors and the extensors in the forearm, because there are so many. So, I mean, there's extensor digitorum, extensor carpi radialis, extensor carpi ulnaris, extensor carpi radialis longus. I mean, it's just many. I don't know the exact number, but it's a whole lot of flexors that flex your wrist, and extensors that extend your wrist. So one example is the extensor carpi radialis longus. That is the name. The 4 terms that I underlined is the whole name. Extensor means that it extends. Carpi means the wrist. So what you're talking about is basically holding your wrist straight. And then radialis would be on the thumb side, and longus just means that the muscle is long. Okay. If it was brevis, it would mean that it was a short muscle, but longus means that it is long in length. So extending at the wrist just means your wrist is straight. Flexing at the wrist means like if you curled your wrist toward your body, like when you're not a dumbbell curl exactly, but like a wrist curl that you can do, to work out your muscles. Okay, and fascicle arrangements. This is probably something that you wouldn't be familiar with, so I need to explain it. Some muscles have a circular arrangement, and those muscles we call sphincters. And also, not just sphincters, but like the orbicularis oculi and the orbicularis oris. Those are circular arrangements. Those are the circular muscles that surround your mouth and your eyes. And then you have muscles that converge. So they have several parts that converge into one. You have muscles that have a parallel arrangement, and pinnate means 5. So an example of a pinnate muscle is the extensor digitorum, because you have 5 digits. So it extends the wrist, extends your fingers. Since you have 5 fingers, there's 5 parts of that muscle. So it's called a pinnate. Here's some pictures. The pectoralis major is a convergent. Convergent ends up looking kind of like a fan. You see how the fibers are arranged kind of like a fan. There's fusiform. The biceps brachii is fusiform. That's going to be kind of where it tapers at each end. So like that. And then fuses together at each end of the muscle, at the origin and at the insertion. Then parallel muscles, where the muscle fibers run parallel. And then you have pinnate, multipinnate, unipinnate, bipinnate. And like I say, probably the one that makes the most sense to me is the extensor digitorum longus, which is considered unipinnate, but I just always remember it because a pentagon is 5 and there's 5 digits. So if you look at the chart over on the right, you can see a convergent muscle would be like a circular. That's wrong. Huh, they have got a mistake on here. So A is a circular muscle, and it is the orbicularis oris. Orbicularis oris. Okay. And then B is a convergent, the pectoralis major. C is the biceps brachii, which is a fusiform. E is a bipinnate. That means that it's pinnate on 2 sides. So on the anterior and posterior side of the shoulder, you have the pinnate arrangement. I'm sorry, it's multipinnate, not bipinnate. It's multipinnate. That's the deltoid muscle. It's multipinnate. So you're going to have not just 2, but many pinnate arrangements. The deltoid muscle is shaped like a triangle, so if that helps. And then the rectus femoris which is part of your quadriceps group of muscles, is a bipinnate, and that's the one where you have 2. Here's one pinnate arrangement, and here's the second pinnate arrangement. Parallel would be the sartorius, which actually crosses over from your hip to your inner thigh, and all of those muscle fibers run straight, parallel, like this. Okay? So pinnate is probably the hardest to understand, but so you may just have to memorize. The deltoid is multipinnate, the rectus femoris is bipinnate, and then the extensor digitorum longus is unipinnate. And just remember, you have 5 digits, and that's how you can remember pinnate. Fascicle arrangements can be used as well when we're talking about circular. The fascicles are arranged in circular rings, and convergent is the ones where they're arranged kind of like a fan. They converge toward a single point. So the pectoralis major was convergent, and the orbicularis oris and orbicularis oculi are circular. But fascicle arrangements are not as common as all the other, as location, the action of the muscle, the direction of the fibers, and the number of origins. Those are much more common than naming by fascicle arrangements. And you definitely don't name by like types of fibers. These are the ones we just went over. And if you want to go over pinnate a little bit more, says they are short fascicles that attach obliquely to a central tendon running the length of the muscle. Unipinnate only attached to one side of the tendon. So the extensor digitorum longus is kind of like this, okay? This is I can't draw very well, but this is the muscle. It kind of runs down the middle of your forearm, and then it has 5 tendons that attach to all 5 of your digits. And then bipinnate and multipinnate. Bipinnate was the rectus femoris, which has 2 pinnate fascicles, and multipinnate would be like your deltoid. Okay, so here's your multipinnate deltoid, your bipinnate rectus femoris, and your unipinnate extensor digitorum longus. And actually, I apologize. it is 5 digits, but this is actually for the toes. There is an extensor digitorum in the forearm that has 5, but it's not longest. That's how you can keep them distinguished from each other. In the forearm, it's called just the extensor digitorum, and it is also pinnate. And then the extensor digitorum longus is in the lower leg. Okay. Fascicle arrangements, most common are circular, convergent, parallel, fusiform, and pinnate. The fascicles determine the muscle's range of motion, the amount of different types of movements, like we talk about the range of motion of joints. The shoulder joint has the greatest range of motion. So muscles that have the greatest range of motion allow the most different types of movements. And the muscle's power is determined by the number of fibers, the length of the fibers, so the number of muscle fibers, the length of the muscle fibers, and the type. I think we learned in chapter 9 that we had fast muscle fibers and slow muscle fibers, so type 1 and type 2. So depending on which type also would determine the power. Okay, now skeletal muscles are arranged with the bones that they're attached to into lever systems. And I want you to start understanding what the lever is, the effort, and the load, because you're going to learn arrangements of lever systems. You can have the lever with the effort in the middle between the lever and the fulcrum. So that would be lever, effort, fulcrum, or you can have, let's see, I know you can have one where it's F, L, E, the fulcrum, the lever, and the effort. So we're going to learn patterns of levers like that. So every time we talk about a different muscle or group of muscles, we will learn it as, what type of lever system that it is. So what acts as the lever is the bone. It's the bone that moves. And the point that it moves on, which is usually your joint, is the fulcrum. So the joint is the fulcrum. The effort is the force supplied by the muscle. So the muscle itself is going to represent the effort. The load is the weight. It's the weight that's having to be moved. Okay, so it's going to include the bone, the tissues, and any added weight that's moved by the muscle. So the muscle itself is the effort, the lever is going to be the bone that moves, and the fulcrum is the joint. So let me see here. One that I can show you real quick. This is my beautiful drawing of a forearm, and then you have the elbow joint and the upper arm. And so this is the elbow joint. That would be your fulcrum. I'm just going to put F. And then the biceps is actually attached. It has the origin at 2 different points, which is why it's called bicep. But it has the insertion at 1. And the load is going to be your forearm. So this is the load. Your forearm is what's being lifted. So the bone and the muscle and all that tissue that's being lifted up whenever you do a flexion of your elbow. And then this is the effort, which is the insertion of the muscle. So it's going to be LEF, that type of arrangement. which is a third class lever system, by the way.